a mercury in glass thermometer made of a glass capillary of uneven bore radius. When calibrated against a correct thermometer produces the curve shown in the figure. Here theta P is the reading of the correct thermometer, and theta F is the corresponding reading of the uneven thermometer. Several students have deduced the shape of the bore of the capillary tube by considering the above curve. The follows. Which of the following figures represent the best model of the shape? When increasing cross-sectional area, reading of this thermometer is increasing. It means gradient should be decreasing. Therefore, for the given graph, we can observe maximum thickness for TU part, maximum thickness for this part. And we can compare other parts relative to it, and we can get the correct answer is 2. Consider the following statements made about the capability of given thermometer to produce an accurate value for a temperature measurement. Statement A: in situation where quick changes of temperature with time have to be measured, the given thermometer must be one having large variation of thermometric property with temperature. Statement A is given as in situation where quick changes of temperature with time have to be measured, the given thermometer must be one having large variation of thermometric property with temperature. Large variation means there is a large variation means there is a large gap between the minimum measuring temperature and maximum measuring temperature. It is not depending. We have to consider accuracy. It is not depending. Then A is incorrect. Then B, thermal capacity of the thermometer must be negligible when compared to the thermal capacity of environment of which the temperature is measured. Yes, it is correct. C, thermometer property must have linear variation. Linear variation is not compulsory. When considering a thermometric property like resistance, it is not a linear variation. Then only B is true. Answer is 1. The different type of thermometers P, Q, R having a temperature range of 0 to 110 degrees are kept at room temperature of 30 degrees, were simultaneously dipped into a large oil bath maintained at 100 degrees Celsius at time t equals 0, and their readings theta were recorded with time. Curves in figure show the variation of theta with t. For 3 thermometers, consider the following conclusions made about thermometers after analyzing the 3 curves. Statement A: P is the most sensitive thermometer. Yes, we can consider given graph. P has a maximum gradient. Gradient of P is greater than other two curves. It means the reaction time of thermometer P is a small value. But when considering sensitivity, it is not depending with reaction time. We have to consider only the gap between two readings of thermometer. Then considering sensitivity, then we can't get P is the most sensitivity one. It has a small reaction time, but we can't get sensitivity by using given graph. A is incorrect. B, thermometers P and R are accurate but not Q. We can observe that the final temperature of three thermometers, P and Q, are 100 degrees. So P and R are 100 degrees. But Q is less than 100. It is like this. It is correct. We know the temperature of coil bath is 100 degrees. Therefore, final reading should be 100 degrees. In part C, the scale of thermometer R is not linear. The scale of thermometer R is not linear. Yes, we can observe the curved part at the end of the graph. But this part is linear. Therefore, we can't get it as a correct statement. Then only B is true. Answer is true. Radii of capillary tubes of two mercury glass thermometers, A and B, having equal volume of mercury inside their bulbs are R and R over 3 respectively. When the temperature of the bulbs are increased by 1 degree Celsius, the ratio change in length of mercury column in A divided by mercury column in B is approximately. Neglect the expansion of gas. They have given a same initial volume. There is a same initial volume because of the volume of bulb in thermometer A is equal to the volume of bulb in thermometer B. Then there is an initial volume. We know that change of volume is V1 gamma theta. We have to consider that only mercury is expanding. It means gas is not expanding. We have to consider only mercury volume. Then change of volume is depending on initial volume. Now there are same initial volumes. Therefore, change of volume is a constant value for both thermometers. And we can get change of volume is equal to the cross-sectional area into height of mercury column, increased height of mercury column. Then A1 H1 should be equal to A2 H2 for both thermometers. Cross-sectional area of thermometer A, we can write 5R squared into HA. HA means increasement of mercury height for the thermometer A when increasing temperature by 1 degree. Area of second one, 5 R over 3 squared. Radius is R over 3, HB. Now we have to subject HA over HB ratio. We can cancel out pi and pi, R squared, then HA over HB is 1 squared 1, 3 squared 9, 1 over 9. Then answer is 1. A certain liquid in gas thermometer with a uniform bore radius has been calibrated using the boiling point of water and melting point of ice. Of the following properties, what is the most essential property that the thermometer liquid used in thermometer must possess? 1. High volume expansivity. 2. Uniform volume expansion. High thermal conductivity. Low specific heat capacity. Low vapor pressure. We have to decide the most essential property. We can consider uniform volume expansion. High volume expansivity, high thermal conductivity, low specific heat capacity, low vapor pressure are given other physical quantities. Low vapor pressure is not essential. When considering other 4 thermometric properties, if there is a uniform volume expansion, we can get a linear scale. It is not compulsory, but the most suitable one is 2. Then answer is 2. 2 mercury in gas thermometers P and Q are to be constructed with P having large bulb of mercury than Q. The both calibrated in range 0 to 100 degrees. Assume that walls of both bulbs have same thickness. Consider the following statement. Using the capillary tube with appropriate uniform bore radius, the 2 thermometers can be constructed have statement A, the same capillary length between 0 and 100 marking. Yes, we can control bore radius such that there is a same height difference for both thermometers. A is correct. B, the same response time for rapid changes in the measuring temperature. It is false. Radius of bulbs are different. Therefore, initial mercury volume is not equal. Therefore, there is a difference between response time of 2 thermometers. C, a higher sensitivity in thermometer P than sensitivity of Q thermometer. P having a large bulb, therefore, according to volume expansion equation, delta V is a large value, therefore we can get high sensitivity for P thermometer, then C is correct. A and C correct, then answer is 4. Which of the following statement is incorrect regarding thermometry? 1. There must be a measurable physical quantity that varies with temperature. Yes, it is correct. Then B, 2. Mercury gas thermometers consist of a thin walled glass bulb. Yes, if there is a high thickness for a glass bulb, we can't get readings immediately. It is depending to the response time and accuracy. Therefore, statement 2 is correct. 3. By using a mercury gas thermometer with a large mercury bulb, the range of measurement can be increased. No, it is false. Then incorrect statement is 3. We know that range of thermometer is depending on thermometric material. If we are considering mercury, the range of thermometer depending on melting point or freezing point of mercury and boiling point of mercury. It should be in liquid condition for the mercury glass thermometer. Therefore, it is depending on thermometric material. We can't control the range by using the size of bulb. Third statement is the incorrect one. Answer is C.